Electrofishing is a method where you're putting an electric current into the water which momentarily stuns the fish. And so we can capture the fish, measure them, weigh them, tag them, and then release them at site. And it helps us record the diversity and the abundances and size ranges of fish in that area. At the Arthur Rylah Institute, or ARI, most of our electrofishing boats are made by an American company, Smith Root. Smith Root make a range of electrofishing boats with varying conductivity ranges. The upper rating of these boats is about 25,000 electrical conductivity units. ARI currently has 5 different electrofishing boats. There's 2 large boats that are Smith Root boats, 2 medium boats which are also Smith Root boats, so you've got Smith Root generators. And we've recently purchased a new unit from the German company Grassl, which works in waters with much higher conductivity. The Smith Root boats are limited to 13,000 electrical conductivity units, which is about a quarter seawater. The smaller boats or medium boats are limited to about 5,500 units, whereas the new boat we've got can go all the way up to seawater or very close to it. So this unit's a new unit that's going to open up great opportunities within Australia but also across the world. This unit was developed by Grassl in conjunction with ARI, and it was specifically made for us as a prototype, and part of that was that we would do some of the on-ground testing to see how it worked once it was built and provide feedback to Grassl for further production. With the modifications we've had to make since it came here, overcoming some of the troubleshooting problems, it's working fine. It is the only one currently working in the world. The Grassl electrofishing unit is a really valuable tool. It allows us to sample complex habitats and estuaries which have been inaccessible in the past. It also samples a range of species that aren't usually caught with conventional netting methods. This unit will open up areas into researching estuarine and near marine waters. So you're looking at a lot of recreational species such as the black brim, the dusky flathead, the mullet and the luderick, but it'll also open up the biodiversity research and just the connectivity importance of flows to those systems for those fish, and also for some of the other diadromous fish that live in freshwater and move down to estuaries to breed.
Okay, so this is the Barwon River, and this is the Barwon River Barrage, which is a barrier to fish movement on this system. It was built to stop saltwater incursions upstream so that farmers could utilise the water for irrigation. So what happens is that below this barrier, it's estuarine water, and it actually gets up to about 54,000 EC, electrical conductivity, and seawater is about 55,000, so it's actually pretty close to salt water a lot of the time. And then upstream of it, it's fresh water, and the EC of that is about 1800. It varies a little bit, about 1800, but that's fresh water. So you've got fresh water, salt water interface because of this dam. So today we did electrofishing downstream of here, and we caught a number of species, including estuary perch, brim, luderick, and they're estuarine species.
Another advantage of the Grassl electrofishing unit is that a site is completed relatively quickly compared to netting, which is quite time consuming and may require returning to the site the following day to retrieve the nets. The fish captured by electrofishing also recover very quickly, and they are returned to their environment much sooner than other conventional netting methods. At the moment, the electrical conductivity range for the Grassl is from freshwater down below 10 EC, which is really mountainous streams. But for the larger water bodies, at the moment we're using it in a range of conductivities from that fresh component right up to virtually seawater. An example of that is we've used it in the Gippsland lakes along the rock wall adjacent to the ocean. So it's a really promising technique that's working well.